to the series, to another lesson in this Terraform series, where we are just getting to learn the fundamentals and exploring the topic of Terraform. So, up until now, you are about familiar with creating configuration files and setting up, deploying them into your cloud account. And today, we will be looking at Terraform backend setup, and this is how you will be securing your backend. So if you're using Terraform and storing your state files locally, you are one laptop crash away from disaster. In this video, I'll show you how to set up a remote backend using AWS S3 so your Terraform state is always safe, shareable, and production ready. In today's lesson, we'll cover what a backend is, why it matters, and walk through a full hands-on setup. If you're new here, welcome. I'm Ronel Hapula, and I help simplify DevOps. Subscribe to my channel if you're ready to make your infrastructure great and bulletproof. And stay tuned for this lesson where we're learning about how to set up Terraform for your backend. Now, let us just discover what the local state file is about. In Terraform, your state file keeps track of what has been deployed to your cloud account. By default, it is stored on your local in a file called terraform.tf state. But this is risky because if the file is lost, you lose track of your infrastructure, right? And you you will have a really hard time regaining that, and you'll probably need to start from scratch. You are at the risk of not being able to collaborate safely with your team members, and you are open to drift and conflicts in your configs or in your infrastructure that is deployed, and also uh, production failures, which is chaos or disaster in a production environment. So then, how does the backend then solve this potential issues? A backend is where Terraform stores its state file remotely. So first, on default, it's local, but the backend will store your state file remotely. So tools like S3, services like S3, Azure Blob, Terraform Cloud, these are the services where we use to store our state file remotely. And today we'll set it up on AWS S3. Okay. So here's what you need to follow if you want to follow along with this lesson. You need an AWS account. Free tier is advisable. You also would need an S3 bucket that you created in your free tier account, and a Dynamo DB table for state locking. And then you also need your Terraform installed and initialized. Okay, so here we are, right where we were in the same repo that we were using in our previous lessons. So don't forget to go back, check in this series to just catch up with what we've been doing in this Terraform series. So here in my EC2 version repository, this is the parent folder. I have created the backend the Terraform file, and here I'm specifying my backend. So right, that is just typo. So I have a block for Terraform, and in it I'm configuring the backend, naming it S3 because I'm using an S3 bucket. And then I am also specifying the bucket. This is the bucket name. So I have a bucket with this name in my AWS account. and I'm specifying that this TF state that is on my local should be saved with this name in the root folder. So it can be a path. Maybe you have a dev TF state, a pre TF state. I can actually also just do that. I can say demo forward slash in the demo folder, create a demo folder. In the demo folder, specify, uh, well, name this actually. I first need to create the demo folder here, right? So right here, I'm going to create the folder, and in it, I'm going to say demo. And in the demo folder, that's where the key will be created. So that's the path, and it's right here. And then I have Dynamo, um, a DynamoDB table, and that is the name S3 lock mechanism. So that's for locking your state file, so that not multiple people cannot write to your state or read from your state at the same time. And then it's in the region. The region is specified. This is in EUS1, and then I'm encrypting the state file in the S3 bucket. So I'm happy with this, and I'm going to save it. And then what I'll do then from here is I will say Terraform init. And okay, so that is not happy with what I'm doing. So once the backend has changed, because this is essentially what's happening, I'm migrating the state from my local to my remote. There is a flag that you need to append onto your Terraform init. So I can run Terraform init. If you want to attempt the automatic migration of the state, use the dash migrate dash state file. If you wish to store the current configuration with no changes to the state, um, then you use reconfigure. All right, so I'm going to use migrate state because I want to automatically migrate this existing state. And it is not happy with the key that I have. Let's see, so we'll take that away and we'll save. It doesn't like the forward slash, so we'll save that and we'll say migrate state. And it's noticing, as you can see here, it's noticing that the backend configuration has changed. And Terraform has detected that the configuration for the backend has changed, and will now check for existing state so that it can migrate it to the cloud. Okay, so we have reconfigured successfully. This is good. So now from here on, we will now be able to relocate the state. From this point on, your state will be remote. So what I can do now is just say Terraform um, apply the existing state, and it will just refresh on what the state is, and then it will apply any changes. Yeah, so we'll give it a moment. Now, what's different in this process is that it was acquiring a state lock, right? It is looking to see if there is any, um, if there is a lock on the state. If there's no lock, the lock is implemented by the DynamoDB table. If there's no reading or writing on the state file, then you are able to continue with whatever you want to apply your changes, right? And if there is someone busy with the same state, then it will block you from being able to um, write to the same state. Okay, so I have a EC2 instance here. And this is the planned resources that I will be applying. You can just say yes, but I won't be doing that. And then you will see that in your folder that the TF state is is created. So now you've successfully migrated your state to the remote, and this can be your environment. And I'm using it for demo, but it could be dev, it could be your pre-prod, it could be your production. You can separate your state file into one bucket, per different with different keys, and you can be able to migrate them to be um in the remote. So
So
let's just refresh on recap on the caveats that we have. Do not use any so one, don't hard code any of your credentials. I'm using default. It's a profile that is in a hidden folder where my credentials are, that I'm able to log on to my cloud account. So you I urge you to use environment variables wherever possible, or AWS CLI to authenticate. Don't store any, number two is don't store any sensitive data in variables that end up in the state file. So when you have your variables file, make sure that it is clean of any sensitive data or identifiable data that might end up in a shared folder like your state file. Even though it's encrypted, it is still viewable for whoever is able to access that. And lastly, always enable locking with your DynamoDB. Right? So always enable the locking, create a DynamoDB table or similar depending on your cloud environment, and enable the locking mechanism that it allows
okay,
you. So
so
this
now
is
you
your Terraform is safer and more scalable. If this helped you avoid a future headache, don't forget to like and subscribe. And if you want to see how to automate all of this with GitHub Actions, hit the subscribe button because that's what we're covering next. So drop a comment if you got stuck or want help configuring your own backend, and I will be seeing you in the next one. Thank you.